everyone, and welcome to Voice AI Decoded. I'm Emma, your AI product lead, and I have to say, a pretty enthusiastic 11labs power user. Laughs. When I say power user, I mean it. My team literally migrated our entire voice AI infrastructure to 11labs last year, and oh my god, the results were incredible. We saw a 10x, yes, 10 times improvement in user engagement. And today, we're diving deep into the 11labs-python library, which honestly changed everything for us. I'm joined by the brilliant James, who's going to help us understand what makes this technology so special. James, I'm so excited to have you here.
Thanks for having me, Emma. I'm James, and I've been working in voice AI architecture for about 8 years now. I've contributed to several speech synthesis systems, and I have to say that what 11labs has accomplished is genuinely impressive from a technical standpoint. The 11labs-python library we're discussing today is essentially a Python SDK that abstracts away all the complexity of working with the 11labs API. What's fascinating is how it handles everything: text-to-speech, voice management, speech-to-speech conversion, and even conversational AI, through a unified client that makes implementation remarkably straightforward. I'm looking forward to breaking down how developers can leverage this to create voice experiences that actually sound human, not robotic. And we'll get into the nitty-gritty of implementation details that make this possible.
Hey everyone, welcome back to Tech Voice. I'm Emma, and today we're diving deep into the 11labs client with my good friend James. So James, I've got to say, when my team switched our entire voice infrastructure to 11labs last quarter, the difference was just mind-blowing. Our user engagement jumped like 10x within weeks, but I'm curious for starters. For developers who are just getting started, what exactly is the 11labs client and why is it so powerful?
Great question, Emma. At its core, the 11labs client is essentially your command center for accessing all of 11labs' voice AI capabilities through Python. Think of it like a universal remote control for voice AI. Instead of dealing with complex HTTP requests and response handling directly, you get this elegant abstraction layer that gives you programmatic access to everything: text-to-speech conversion, voice management, model selection, all through a consistent interface. The real beauty is how it simplifies what would otherwise be pretty complex API interactions into just a few lines of readable code.
Oh, that makes perfect sense. I remember before we integrated 11labs, our devs were spending days writing boilerplate code just to handle basic TTS requests. So let's get practical. How would someone get started? When we implemented it, I was amazed at how quick the setup was compared to our previous solution, which shall remain nameless, but was a complete pain to integrate.
It's refreshingly simple. You start by installing the package with a standard pip install 11labs. Then creating a client is just 2 lines of code. Import the 11labs class and instantiate it. You can either pass your API key directly or set it as an environment variable, which is what I recommend for production deployments. Something like from 11labs.client import 11labs, followed by client showcase 11labs API key your API key. That's literally it. You now have access to the entire platform. What's interesting from a design perspective is how they've structured the client to use resource-specific components. So client.text to speech gives you TTS functions, client.voices lets you manage voices, and so on.
Wait, so you mean I can access everything through this one client object? That's actually why we chose 11labs over competitors. Our previous provider had 5 different SDKs with inconsistent interfaces. So speaking of text-to-speech, we implemented this for our product tours and saw a 63% increase in completion rates. The voices just sound so natural that users stay engaged. What's happening technically when someone calls that text-to-speech function?
Behind that simple function call is some seriously impressive engineering. When you call client.text-to-speech.convert, the client is handling all the API communication, proper formatting of the request payload, authentication, and even retry logic if there's a network hiccup. The models powering this, particularly 11 multilingual v2, are state-of-the-art transformer architectures fine-tuned specifically for natural prosody and emotional expression. That's why you're seeing those completion rate increases. There's a massive difference between voices that are just intelligible versus voices that sound genuinely human with appropriate pausing, emphasis, and emotional tone. Under the hood, the client is also optimizing things like streaming for longer content and handling binary audio data correctly, which would be pretty tedious to implement manually.
That makes so much sense. And the ROI for us was crystal clear. We calculated that the development time saved by using the client, instead of building our own integration, was about 120 engineering hours, which translated to roughly $18,000 in direct savings. But the real game changer was how quickly we could experiment with different voices and models. James, I'm curious about those different components you mentioned. Our team primarily uses text-to-speech, but I know there's a whole ecosystem there.
Absolutely. The architecture is quite elegant. The client is organized into these logical components that map to different API resources. So, beyond text-to-speech, you've got client.voices for creating and managing voice profiles, including the voice cloning capabilities that are pretty unmatched in the market. Then there's client.models, which lets you access different speech synthesis models, optimized for different use cases. What's particularly well designed is how they've implemented an async version of the client too, which is crucial for production applications where you don't want to block your main thread while waiting for audio generation. The performance difference can be substantial. I've seen systems handle 5-10x more concurrent requests with the async implementation versus synchronous calls. For companies processing thousands of TTS requests, that's the difference between needing one server versus 10.
So James, I'm really excited to dive into voice management today. Since we migrated our entire voice AI stack to 11 Labs, our user engagement has literally gone through the roof. We're talking 10x improvement. The voice management capabilities were a game changer for us. I'd love to hear your technical perspective on what makes 11 Labs' approach to voice management so powerful compared to other platforms we evaluated.
That's impressive engagement growth, Emma. Voice management in 11 Labs is essentially a sophisticated casting system for your audio projects. Think of it like having a virtual voice casting director. What sets their implementation apart is the granular control over voice parameters while maintaining natural speech patterns. Unlike competitors that often give you a limited set of static voices, 11 Labs lets you browse pre-made voices, get detailed information about them, adjust fine-grained settings, clone existing voices, and organize your collection. All through a clean API. The architecture behind it balances flexibility and performance in a way that's quite unique in the industry.
You know, that flexibility was exactly what sold our product team. Before 11 Labs, we were using, I won't name names, but we were stuck with these robotic-sounding voices that our users would immediately recognize as AI. Our customer feedback scores on audio quality were abysmal. So, could you walk us through how someone would actually implement voice management in their application? I remember the code being surprisingly clean compared to what we were using before.
Absolutely. The implementation is refreshingly straightforward. Let me break it down. You start by initializing the 11 Labs client, then you can access all available voices with just a couple lines of code. For example, client, not door 11 Labs, followed by voices, not client.voices.search. This gives you access to both pre-made voices and any custom ones you've created. What's clever about their design decision here is that they've abstracted away a lot of the complexity. Each voice has properties like a unique ID, name, description, and customizable settings. You can easily fetch specific voice details with voice as taos client.voices get ICD. The API design prioritizes developer experience without sacrificing functionality, which is probably why you found it so much cleaner than alternatives.
Wait, so you mean I can just call these methods and get all the voice data instantly? That makes sense why our integration time dropped from weeks to days. One thing that really paid off for us was the voice customization. We created character voices for our educational app that maintained consistency across thousands of lessons. Our content team calculated a 72% reduction in production costs compared to traditional voice recording sessions. The settings for stability and similarity were particularly powerful. Can you explain how those actually work under the hood?
The magic happens in how 11labs parameterize their voice model. Those settings, stability, similarity boost, style, speaker boost, and speed, are essentially controlling different aspects of the underlying neural network. Stability, which ranges from 0.0 to 1.0, determines how consistent the voice sounds across longer passages. At higher values, you get fewer variations, but potentially less expressiveness. Similarity boost controls how closely the output matches the original voice sample. Higher values preserve the voice's unique characteristics but might sound less natural in certain contexts. The real technical achievement is maintaining natural prosody and emotional range while allowing these adjustments. Behind the scenes, there's a complex balance of model weights that most competitors haven't mastered. This is why your educational content maintained character consistency. The model architecture preserves voice identity even when expressing different emotions or speaking styles.
That explains a lot. We actually A/B tested conversion rates with different stability and similarity settings and found a sweet spot that increased our free-to-paid conversion by 43%. But the feature that really blew me away was voice cloning. We took our CEO's voice, created a custom model with just a few minutes of audio, and now our onboarding videos sound like she personally recorded every single one, even in different languages. And the whole thing runs in production with minimal latency. I don't think I've seen any other platform that can do voice cloning that efficiently without massive computing resources. What's your take on their voice cloning implementation?
11labs' voice cloning is definitely industry-leading from a technical standpoint. They've solved several hard problems that competitors struggle with. First, they've optimized the model to require surprisingly little training data. Those few minutes of your CEO's voice would have needed hours on other platforms. Second, their inference pipeline is remarkably efficient, which explains the low latency you're seeing in production. They've implemented a clever architecture that separates voice identity from speech content, allowing for that natural cross-language capability you mentioned. From a deployment perspective, they've also considered scale. The API handles high-volume requests with consistent performance characteristics. For teams considering implementation, I'd recommend setting up voice management with version control for your custom voices and implementing A/B testing like you did to optimize engagement metrics. The ROI on this approach is compelling, especially when you factor in the reduced computing costs compared to running these models yourself.
So James, now that we've covered voice management in 11labs, I'm really curious about the models aspect. When I migrated my company's voice AI stack to 11labs last year, one of the biggest game changers was actually the flexibility of their different models. Can you break down what these models actually are for our listeners?
Absolutely, Emma. Think of 11labs' voice models like different types of musical instruments. They all create sound, but a piano gives you a different result than a violin, right? In technical terms, these models are the AI engines powering the voice generation. Each has been trained with different parameters and data sets to excel at specific tasks. Some prioritize quality, others speed, and they vary in language support capabilities.
That's such a helpful analogy. And I can testify that selecting the right model made a huge difference for us. We were using a competitor's one-size-fits-all approach and switched to 11labs' multilingual V2 model. Our user engagement jumped nearly 10x because the voice quality was so much more natural in multiple languages. But there's a cost consideration too, isn't there?
That's impressive engagement data, Emma. And yes, there's definitely a cost-benefit analysis to consider. More advanced models typically consume more credits, but often deliver superior results. What's unique about 11labs' approach is how transparent they make these trade-offs. For instance, their API lets you examine model properties like this. Client.models.list will show you each model's capabilities, whether it supports text-to-speech, voice conversion, and which languages it handles. This granularity is something I rarely see in competing platforms.
That API access is crucial. One of our developers actually built a dynamic model switching system that automatically selects the most cost-efficient model based on the content type and language. For long-form content in English, we use one model, but for short multilingual snippets, we switch to another. We calculated a 22% reduction in our voice generation costs while maintaining quality. Have you seen other creative implementations like this?
That's a brilliant implementation. I've worked with several companies doing similar optimizations. One streaming platform actually runs A/B tests on different models for different user segments. They found that for their younger audience, the ultra-realistic models drove higher retention, while their older users actually preferred slightly less perfect voices, found them less uncanny. The code to implement this is surprisingly simple too. You can use something like suitable models, as M for M in models, if M can do text to speech, and len m.languages 5 to programmatically filter models by capabilities. This kind of flexibility just wasn't possible with previous generation platforms.
Wait, so you mean you can actually filter models by the number of languages they support? That would have saved us so much testing time. What about latency considerations? We found that for our real-time application, switching from our previous provider to 11labs' multilingual V1 model cut response times by almost 40%, which was actually more important than ultra-high quality for that particular feature.
Exactly right. Latency is a critical factor that's often overlooked. 11labs has done some impressive optimization work there. In production environments, I typically recommend their V1 models when response time is critical, like for real-time conversations or interactive applications. For pre-rendered content, where quality matters more, the V2 models shine. The real power comes from their API design that lets you make these decisions programmatically. You can even set up fallback patterns where you try a high-quality model first, but fall back to a faster one if latency thresholds are exceeded. That kind of control just doesn't exist with most competitors who give you a single model and call it a day.
So James, we've been talking about all these different AI models in 11labs, but I'm dying to get into the real magic. The text-to-speech conversion. That's where the rubber meets the road for my team. We actually migrated from another provider last quarter and saw engagement jump by over 300% almost overnight. The difference in quality was just mind-blowing.
That's a significant improvement, Emma. And you're right, the models are just the foundation. Text-to-speech is where 11labs truly shines. At its core, TTS is essentially translating written words into spoken language. But what makes 11labs different is how we handle the neural processing to create truly human-like speech patterns. It's not just reading text, it's interpreting it with natural cadence, emphasis, and emotion.
Exactly. And implementing it was surprisingly straightforward. Our devs were shocked when they saw how clean the API is. Just a few lines of code and suddenly our entire content library had this incredibly natural voice. We literally had customers asking if we'd hired voice actors. And the best part? Our compute costs dropped by 40% compared to our previous solution while getting better quality. That's what I call a win-win.
The simplicity is intentional. Let me walk through a basic implementation. You just initialize the client, then call the text to speech.convert method with your text, specify which voice ID you want to use, and optionally which model. Under the hood, there's complex neural processing happening, but we've abstracted all that complexity away. For most use cases, it's literally 3-4 lines of code to get production quality audio.
And we discovered those voice settings were game changers for our use case. We create personalized financial summaries, and tweaking the stability and similarity boost let us fine-tune voices that sound consistent but still conversational. What's actually happening technically when we adjust those parameters? Our team had different theories.
Great question. When you adjust stability, you're essentially controlling how much variation the model introduces between utterances. Higher stability means more consistent output, but potentially less expressive. Similarity boost controls how closely the output adheres to the original voice samples. Behind the scenes, these parameters are influencing attention weights in the neural network. We're effectively guiding the model's focus between faithful reproduction and natural variation. It's a delicate balance that most competitors don't expose to developers.
Wait, so that explains why we got such different results from our previous provider. They had a one-size-fits-all approach that sounded robotic for longer content. With 11 Labs, we're processing entire financial reports, sometimes 50-plus pages, and the voice maintains consistent quality throughout. Our customer satisfaction scores for our audio reports jumped from 6.8 to 9.3 out of 10. Have you seen other companies handling these kinds of volume requirements?
Absolutely. The streaming capability is crucial for those longer texts. Instead of waiting for the entire audio to generate, you can start processing it chunk by chunk. We have clients in publishing who are converting entire novels and media companies generating thousands of news articles daily. For production environments, I recommend implementing proper request batching and retry logic. Also, monitor your token usage through our dashboard. We've seen companies save up to 60% on costs just by optimizing their prompt structures. The real-time processing capabilities really set 11 Labs apart when you're working at scale.
So, James, we've been talking about how 11 Labs' text-to-speech has been transformative for our product workflow. But what happens after you generate all this synthetic speech? Our team was struggling with processing hours of mixed audio content from user interviews. We had this massive backlog of recordings with terrible background noise from cafes, offices, you name it. That's when we discovered 11 Labs' audio processing capabilities.
That's actually a perfect transition, Emma. Once you've got your audio, whether it's AI generated or human recorded, you often need to clean it up or manipulate it in some way. 11 Labs has built some really impressive audio processing tools that go way beyond what most people expect from a voice AI platform. Their audio isolation feature, for example, is something I've seen teams completely restructure their workflows around.
Oh, absolutely. The audio isolation was a game changer for us. Before switching to 11 Labs, we were using this complicated chain of 3 different services just to clean up our recordings, and it was costing us nearly $8,000 monthly. With 11 Labs, we're down to under $2,000 and getting better quality. Our podcast production time dropped from 4 days to just 1. Have you seen many other companies implementing this in production environments?
I've implemented it across several enterprise projects, and what stands out is how it handles real-time processing. The streaming capabilities are incredibly efficient. You can start cleaning audio before the entire file is processed, which is crucial for longer recordings. The Python implementation is surprisingly straightforward too. You just open your audio file, pass it through the client.audio isolation.stream method, and process each chunk as it arrives. This makes it viable for live applications where latency matters.
The streaming aspect was huge for our customer service division. They're analyzing call center conversations in real time now. But what really blew me away was the speaker separation feature. We were recording these roundtable discussions with 6 different experts, and before, it was this tedious manual process to identify who was saying what. With 11 Labs, it just works. It's like having a virtual sound engineer that can isolate each voice automatically. How does it compare technically to other solutions you've worked with?
It's substantially more accurate, especially with overlapping speech. Most competing solutions struggle when multiple people talk simultaneously. They either merge the voices or misattribute them. ElevenLabs uses a more sophisticated neural approach that creates what I'd call a unique voice fingerprint for each speaker. In benchmarks we ran last quarter, it was 43% more accurate than the closest competitor in complex multi-speaker environments. And what's interesting from an implementation standpoint is that you can pipe this directly into their transcription service, so you get not just isolated audio streams but also speaker attributed text in the same workflow.
That end-to-end capability saved us from building 3 different integration points. I'm curious about one more thing. We're launching in Japan next quarter, and their audio processing needs to handle non-English recordings. Does ElevenLabs perform well with multilingual content? Our current solution falls apart with anything but English.
That's where they really shine compared to alternatives. Their audio processing models are language agnostic by design. We tested Mandarin, Japanese, German and Arabic recordings, and the isolation quality was consistent across all of them. It's because they're not using traditional speech recognition. As an intermediate step, they're analyzing acoustic properties directly. One client in Singapore saw 87% accuracy with a mix of English, Mandarin and Malay. In the same conversation, which was impossible with their previous stack. For your Japan launch, you should be in excellent shape.
So, James, we've been talking about audio processing and cleaning up recordings, but I'm really excited to dive into what I think is one of ElevenLabs' killer features, speech-to-speech conversion. I mean, this technology literally transformed our customer support training videos. We took recordings from our top agents and converted them into multiple languages while keeping their exact pacing and emotional delivery. Our CSAT scores jumped 22% after implementing this. Have you worked much with this technology?
Absolutely, Emma. Speech-to-speech is fascinating because it's essentially voice transformation at its core, preserving what's being said while changing who's saying it. It's like having a voice actor who perfectly mimics the exact delivery of the original speaker, but with their own unique vocal characteristics, and that's really where ElevenLabs shines compared to competitors, maintaining those micro-expressions, pauses, and emotional inflections that make speech feel authentic. I'd love to hear more about your implementation. Did you integrate directly with their API?
Oh yeah, the API integration was surprisingly straightforward. We were previously using a competitor's solution that required multiple steps. Transcription, then text-to-speech, which meant we lost all the emotional nuance. With ElevenLabs, we just submit the audio file and specify the target voice ID. What impressed our dev team was the streaming capability. We're processing 3-hour customer calls in near real time now, which used to take almost 8 hours of processing with our old stack. The ROI was obvious within the first month, but I'm curious, what's actually happening technically behind the scenes when we convert speech?
That's a great question. Behind the scenes, it's using a sophisticated pipeline that doesn't rely on the traditional transcribe then synthesize approach. Traditional systems first convert speech to text, losing all prosody information, and then generate new speech, essentially creating all new timing and intonation. But ElevenLabs uses what's essentially a neural voice transfer model that preserves the paralinguistic features, the rhythm, stress, intonation, and emotional markers. Let me show you how simple the code implementation is. You just need something like client.speech to speech.convert, audio's file, voice ID, your target voice. The simplicity hides the complexity of what's happening, which is why their streaming capability is so impressive. They've optimized a computationally intensive process to work in chunks.
That's exactly what won over our engineering team. The clean API meant we could implement in days, not weeks. And speaking of streaming, we actually built a real-time voice conversion feature for our sales team's international calls. They can now speak naturally in English while the customer hears everything in their native language with the sales rep's exact tone and emphasis patterns. conversion latency is under 500 meters in production, which feels nearly instantaneous in conversation. We tested 5 different solutions, and 11 Labs was the only one that could handle this without awkward pauses or robotic delivery. Have you seen other companies using the streaming capabilities in production?
I've worked with several media companies implementing this for dubbing workflows. One studio reduced their localization costs by 64% by using 11 Labs speech-to-speech to convert their voice actors' performances into multiple languages. The technical differentiator was the emotion preservation. Other solutions required re-recording emotional scenes because the conversion sounded flat. But there's a performance consideration worth mentioning. For production deployments, I recommend processing audio in 30-second chunks with a 5-second overlap to avoid any seams in the conversion. This pattern also gives you better error handling if any single chunk fails to process correctly. The documentation has some great examples of handling this with async processing for high-volume applications.
That chunking approach is brilliant. We actually had to learn that lesson the hard way when we first deployed. Another thing we discovered is that voice selection makes a huge difference in quality. When we cloned our own voice talent instead of using pre-built voices, we saw a 15% improvement in listener engagement metrics. The voice cloning process was surprisingly quick. About 5 minutes of sample audio gave us production quality results. James, what would you say are the most common pitfalls people should watch out for when implementing speech-to-speech in production?
You hit on a big one with voice selection. I'd add that input audio quality is absolutely critical. Garbage in, garbage out still applies even with these advanced models. I typically recommend a pre-processing step to normalize audio levels and filter background noise. Another consideration is handling edge cases like laughter, sighs, or background music. 11 Labs handles these non-verbal elements better than competitors I've tested, but it's still important to set expectations properly. Oh, and one more thing. When implementing streaming in production, make sure to implement proper retry logic with exponential back-off. The service is reliable, but network hiccups happen, and your architecture should gracefully handle temporary disruptions, especially for real-time applications like your sales calls example.
So James, we've been talking about speech-to-speech conversion, which is amazing, but I'm really excited about what 11 Labs is doing with speech-to-text. Since we integrated their STT API, our meeting transcription accuracy jumped by like 30%. It's been a game changer for our team.
That's impressive, Emma. Speech-to-text is essentially the listening component of conversational AI systems. What's fascinating about 11 Labs' approach is how they've optimized their models specifically for conversational speech patterns. Their Scribe V1 model handles nuances that other solutions miss completely.
Exactly. And what blew me away was the speaker identification. We used to spend hours manually labeling who said what in our user research recordings. Now, the system automatically tags different speakers and, get this, we reduced our post-processing time by 78%. Have you seen how their API handles the multi-speaker scenarios?
Oh, absolutely. The speaker diarization is implemented brilliantly. Behind the scenes, it's using a combination of voice embedding and contextual analysis to distinguish between speakers, even when they have similar vocal characteristics. Let me show you how elegantly you can implement this in just a few lines of code. You'd first initialize the client, then when you call the convert method, you get back this rich transcription object that contains not just the text, but precise timestamps and speaker IDs for each word. So you can do something like,
Wait. So you mean each individual word has its own timestamp? That's way more granular than what we had with our previous provider. How's the performance on longer audio files, though? We sometimes process hour-long meetings.
That's where 11 Labs really shines compared to competitors. Their architecture is designed to handle extended audio without degradation in accuracy. For those hour-long meetings, you're getting consistent performance throughout because they've implemented a sliding context window approach that maintains semantic understanding And yes, every single word gets a precise timestamp, start and end, plus a confidence score, which is incredibly valuable for building interactive transcripts or searchable audio databases. The memory optimization they've achieved is remarkable too. Processing that used to require specialized hardware can now run on standard cloud instances.
The ROI has been incredible for us. We calculated that just from the reduced manual review time alone, we're saving about $4,300 per month. And that doesn't even account for the new use cases we've unlocked. Like, we're now automatically generating blog content from our weekly podcast because the transcription quality is finally good enough to use without heavy editing. Have your clients reported similar results?
Consistently, yes. One media production company I worked with switched to 11 Labs and saw their transcription correction time drop by 86%. But what really differentiated the experience was the API's flexibility. They were able to pipeline the speech-to-text output directly into their content management system through webhooks. The whole workflow, from recording to published transcript, became automated, and the character-level confidence scores let them visually highlight potentially problematic words for quick review. When you combine that level of detail with the speed of processing, well, it's why we're seeing migration from Google and Microsoft solutions to 11 Labs, despite those being more established players.
So, James, we've been talking about speech-to-text conversion, which is absolutely fascinating. But I'm curious, once you've got that text from voice input, what's the next frontier? In my company, we implemented 11 Labs speech-to-text as part of a larger customer service overhaul, and it was like we had all these puzzle pieces but needed something to connect them into a seamless experience.
That's a great question, Emma. What you're describing is exactly where conversational AI comes in. Think of it like this. If text-to-speech gives your system a voice and speech-to-text gives it ears, then conversational AI is essentially giving it a brain. It's connecting those components into something that can maintain a natural, flowing conversation with users.
Oh, that makes perfect sense. So it's not just about understanding individual commands, but actually following a conversation thread. We saw this dramatic shift when we implemented 11 Labs' conversational AI. Our user engagement jumped by 10x compared to our previous solution. People went from giving one-word commands to having actual conversations with our system. What's actually happening under the hood there?
Behind that impressive engagement boost is a sophisticated architecture with several key components working together. You've got the audio interface capturing and playing speech, the speech-to-text component we discussed earlier, but then crucially, there's a conversation manager maintaining state and context across multiple turns. That's what enables those natural feeling interactions your users are responding to so positively.
The context maintenance was a game changer for us. Our previous solution would forget what users said just moments earlier, which was, well, frustrating is putting it mildly. Our support tickets dropped 40% after switching to 11 Labs. But I'm curious about implementation. How complex is it to set up something like this? Our dev team was skeptical about integration time at first.
That's where 11 Labs really shines compared to alternatives. They've abstracted away much of that complexity with their conversation class. Let me walk through a code example. You initialize a client, create a conversation object with your agent ID, then set up callbacks for different events, like when the agent responds or when user speech is recognized. What might take weeks with other solutions can be implemented in days, sometimes even hours. The real engineering elegance is how they've unified all these components while maintaining flexibility for developers.
Wait, so you mean our developers didn't have to build separate pipelines for speech recognition, natural language understanding, and voice synthesis? That explains why our CTO was so surprised by the ROI calculations. We estimated a 3-month integration project, but the team had a prototype running in just 2 weeks, and we were in production within a month. The cost savings alone were substantial, but the real win was how quickly we could iterate based on user feedback.
Exactly. With traditional approaches, you'd be stitching together multiple services, perhaps using one vendor for STT, another for conversation management, and yet another for TTS, each with their own latency, pricing models, and quirks. When deploying in production, those seams become pain points. 11labs' unified approach significantly reduces latency, critical for maintaining natural conversation flow, and simplifies everything from debugging to scaling. Many teams I've worked with have seen real-time processing improvements of 30–50% over piecemeal solutions.
So, James, I've been meaning to tell you, we finally moved our entire voice infrastructure to 11labs for our conversational AI assistant, and the results have been mind-blowing. User engagement is up almost 10x, and the voice quality is so natural that people are actually forgetting they're talking to an AI. But now I'm looking at what's next, and I keep hearing about their webhook system. We're thinking about implementing it, but I'm not entirely sure how it would benefit us beyond what we've already built. What's your take on it?
That's fantastic about your conversational AI results, Emma. Webhooks are definitely worth exploring next. Think of webhooks like this. Imagine you're expecting an important package. You could keep checking your doorstep every few minutes, or you could have the delivery service text you when they arrive. With 11labs' webhooks, instead of your application constantly asking, "Is that audio file ready yet?" Every few seconds, 11labs just sends you a notification when important events happen, like when a text-to-speech conversion completes or when a custom voice creation is ready.
Oh, that makes perfect sense. So we'd be saving all those redundant API calls, checking for status updates. With our previous provider, we tried something similar but had security nightmares. Someone actually spoofed notifications and injected some let's just say colorful language, into our production environment. Does 11labs have any protection against that kind of attack?
Absolutely they do, and it's one area where they really shine compared to competitors. Every webhook comes with a cryptographic signature that you can verify using your secret key. Their Python SDK makes implementation super clean. It's literally about 5 lines of code to verify that a webhook actually came from 11labs and not some attacker. Under the hood, it's using an HMAC-based verification system with timestamp validation to prevent replay attacks. I've implemented it for several clients, and it's rock solid.
That's a huge relief. So what kind of real-world applications have you seen with these webhooks? I'm trying to build a business case for my team to implement this, and concrete examples always help.
I worked with a streaming platform that used webhooks to drastically improve their content pipeline. They're creating audio versions of their articles, and previously they had this clunky system where users would request the audio version and then wait 30–40 seconds while it generated. After implementing 11labs webhooks, they now trigger the audio generation in the background when an article is published, and their app gets notified when it's ready. The audio is waiting before users even ask for it. They saw a 65% increase in audio consumption and reduced their API costs by about 40% because they're not constantly polling for status updates. The implementation was maybe 100 lines of code total.
Wow, that 65% increase is impressive. I can see how we could apply this to our virtual tour product. Right now, we have that awkward waiting period when users enter a new area and we need to generate the narration. With webhooks, we could predict the next likely locations and pre-generate audio, then have it instantly available when they arrive. That latency is killing our retention metrics. Users just abandon if they have to wait more than a few seconds.
Exactly. And what's powerful about 11labs' implementation specifically is that you get granular event types. You're not just notified when audio generation completes. You can also set up webhooks for errors, voice creation events, even projects being shared. The typical implementation pattern is to set up an endpoint on your server, register it with 11labs, and then build a handler that processes these events as they arrive. One client reduced their bounce rate by 32% with this pattern because the experience became so seamless. Oh, and for mission-critical stuff, you can even implement retry logic on your webhook receiver to handle edge cases where notifications might fail to arrive.